When installing new low-voltage cables for light-emitting diode or LED lighting in proximity to existing 5 kV cables, the new cables must maintain 5 kV insulation. The insulation rating of a cable is determined by the maximum voltage that it could be exposed to, irrespective of the actual voltage it is currently carrying. Even if the existing 5 kV cables are being used with LED lights that only require 600 volts, they could potentially still carry 5 kV. To ensure safety and prevent hazards, use cables with an insulation rating equal to or greater than the maximum voltage they might encounter. If all existing 5 kV cables now carry a maximum of 600 volts due to the LED lights, new cables can be rated for 600 volts. Verify the voltage rating of the existing cables before installing any new ones because some may still carry higher voltages. The voltage rating of a cable is not the only consideration. Other factors such as the type of insulation, the conductor material, and the cable size should also be considered. In summary, firstly, assess the maximum potential voltage of existing cables, even if they are currently operating at low voltages with LED lights. Secondly, ensure that new cables installed nearby have an insulation rating equal to or exceeding the maximum potential voltage of the existing cables. Thirdly, if all existing cables are confirmed to operate at a maximum of 600 volts, new cables rated for 600 volts can be used. Fourthly, before installation, verify the voltage rating of the existing cables to confirm that they operate at a maximum of 600 volts. Fifthly, consider additional factors such as insulation type, conductor material, and cable size to ensure the safety and reliability of the installation. Let's delve into these points in more detail. Firstly, assessing the maximum potential voltage involves understanding the original design and specifications of the existing cables. These cables may have been installed to handle a 5 kV load, and their insulation was chosen accordingly. Even if LED lights are now used, the cable's inherent capacity to carry 5 kV remained. Any fault or change in the system could potentially expose these cables to their maximum rated voltage. This assessment also involves reviewing documentation, consulting with experienced electricians or engineers, and possibly conducting tests to confirm the cable's capabilities. Secondly, the insulation rating of new cables installed near existing 5 kV cables must be at least 5 kV to prevent insulation breakdown and potential electrical hazards. Insulation breakdown occurs when the voltage applied to a cable exceeds its insulation capacity, leading to arcing, short circuits, and potentially fires. By using cables with a 5 kV or higher insulation rating, you ensure that the new cables can withstand any voltage surges or faults that might occur in the existing cables. Thirdly, if all existing cables are confirmed to operate at a maximum of 600 volts, new cables rated for 600 volts can be used. This confirmation requires thorough testing and verification. It is essential to ensure that there is no possibility of the existing cables being subjected to higher voltages in the future. This might involve physically tracing the cables, checking their connections, and verifying that the power supply is indeed limited to 600 volts. Fourthly, before installation, verify the voltage rating of the existing cables. Use appropriate testing equipment such as a multimeter or voltage tester to measure the voltage on the cables. Ensure that the testing equipment is properly calibrated and rated for the voltage levels being tested. Perform the tests under safe conditions, following all necessary safety protocols. If there are any doubts or uncertainties, consult with a qualified electrician or engineer. Fifthly, consider additional factors such as insulation type, conductor material, and cable size. The type of insulation affects the cable's ability to withstand heat, moisture, and other environmental factors. Common insulation materials include cross-linked polyethylene or XLPE, polyvinyl chloride or PVC, and rubber. The conductor material affects the cable's conductivity and resistance. Copper is the most common conductor material due to its high conductivity, but aluminum is also used in some applications. The cable size affects its current carrying capacity. The size must be adequate to handle the anticipated current load without overheating. Moreover, it is crucial to adhere to the National Electrical Code, or NIC, which provides detailed guidelines on cable installation and safety. The NEC specifies the types of cables that can be used in different applications, the ampacity of cables, and the requirements for overcurrent protection. Complying with the NEC ensures that the electrical installation is safe and reliable. In addition to the NEC, the Federal Aviation Administration, or FAA, also has specific requirements for airport lighting systems. These requirements are detailed in FAA advisory circulars and other publications. Ensure that the electrical installation complies with all applicable FAA requirements. When considering the type of insulation, it's important to understand the specific characteristics of each material. Cross-linked polyethylene, or XLPE, insulation is known for its excellent electrical properties, high temperature resistance, and resistance to moisture and chemicals. It is commonly used in high-voltage applications and is suitable for direct burial. Polyvinyl chloride, or PVC, insulation is a thermoplastic material that is flexible, durable, and resistant to abrasion, moisture, and chemicals. It is commonly used in low-voltage applications and is suitable for indoor and outdoor use. Rubber insulation is a flexible and resilient material that is resistant to abrasion, moisture, and chemicals. It is commonly used in low-voltage applications and is suitable for flexible cords and cables. The conductor material also plays a significant role in the performance of the cable. Copper is the preferred conductor material due to its high conductivity and low resistance. It is also corrosion resistant and easy to work with. Aluminum is a lighter and less expensive conductor material than copper, but it has lower conductivity and higher resistance. It is commonly used in overhead power lines and large conductors. The cable size, or conductor size, is determined by the anticipated current load. The larger the current load, the larger the cable size required. The NEC provides tables that specify the ampacity of cables based on their size, insulation type, and installation conditions. It is essential to choose a cable size that is adequate to handle the anticipated current load without overheating. Overheating can damage the insulation and lead to electrical hazards. When installing new cables, it is also important to consider the physical protection of the cables. Cables should be protected from physical damage, such as abrasion, impact, and crushing. They should also be protected from exposure to sunlight, moisture, and chemicals. Cables can be protected by installing them in conduit, cable trays, or underground ducts. Conduit is a rigid or flexible tube that is used to enclose and protect electrical cables. Cable trays are open support systems that are used to support and route electrical cables. Underground ducts are buried conduits that are used to protect electrical cables from physical damage and environmental exposure. Furthermore, proper grounding is essential for electrical safety. Grounding provides a low-resistance path for fault currents to flow back to the source, which helps to trip over current protection devices and prevent electrical shock hazards. All electrical equipment and enclosures should be properly grounded. The grounding system should be installed in accordance with the NEC requirements. When working with electrical cables, it is essential to follow all necessary safety precautions. Always to energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. Never work on electrical equipment when you are tired or distracted. If you are not qualified to perform electrical work, hire a qualified electrician. Consider the environmental factors as well. Cables exposed to direct sunlight should be rated for ultraviolet or UV resistance to prevent degradation of the insulation. In wet or damp locations, cables should be rated for wet locations such as type UF cable. In corrosive environments, cables should be resistant to chemicals and other corrosive substances. Remember that constant current series circuits used in airport lighting operate differently than typical parallel circuits. In a series circuit, the current is the same throughout the circuit, and the voltage varies depending on the load. Therefore, it is important to ensure that the cable is rated for the maximum voltage that it could be exposed to. In a constant current series circuit, the current is maintained at a constant level regardless of the number of lights connected to the circuit. This is achieved by using a constant current regulator, or CCR, which adjusts the voltage to maintain the desired current. If the number of lights connected to the circuit is reduced, the voltage will increase. If the number of lights connected to the circuit is increased, the voltage will decrease. Therefore, it is important to ensure that the cable is rated for the maximum voltage that it could be exposed to, even if the lights are currently operating at a lower voltage. Finally, always document the electrical installation. Keep accurate records of the cable types, sizes, and ratings, as well as the grounding system and overcurrent protection devices. This documentation will be helpful for future maintenance and troubleshooting. Regularly inspect the electrical installation to ensure that it is in good condition. Look for any signs of damage, such as cracked or brittle insulation, corroded conductors, or loose connections. If you find any damage, repair it immediately. Regular maintenance and inspections can help to prevent electrical hazards and ensure the safe and reliable operation of the airport lighting system. Proper cable selection and installation are critical for ensuring the safety and reliability of airport lighting systems. By following the guidelines outlined in this discussion and adhering to all applicable codes and regulations, you can minimize the risk of electrical hazards and ensure the continued operation of the airport. Remember, electrical safety is paramount. If you are not qualified to perform electrical work, hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you to ensure that your electrical installation complies with all applicable codes and regulations.